Okay.
So good evening, everyone. Welcome you all to the 51st SOA Weekly Academic Lecture Series. The topic of this today's lecture is secure image retrieval in cloud storage. So today we have Dr. Sumit Kumar sir is our speaker. So he is currently working as an assistant professor in the School of Computer Science, University of Petroleum and Engineering Energy Studies, Dehradun. He completed his MTech and PhD from IIT Dhanbad. His research area interests are CBIR, secure CBIR, and image crypto systems. So now let's welcome Dr. Sumit sir. Now, sir, you can start.
Thank you, Dr. Abhinav, sir, for inviting me. Thank you, Shikshan Sandhan, for giving me such an opportunity to be at that event. Okay. So, to start with, as you all know, that topic of today's topic is secure CVR and cloud storage. I think uh, it is visible. My presentation.
Sir, I think your voice is not very clear to us. So can you
Voice is
please?
not clear.
Yes. Your voice is not very clear. So can you arrange your microphone, sir?
Yes. I'm just adjusting the microphone. Is it clear now?
Yeah. No, it's fine, sir. Yeah.
Fine. Okay. And my presentation is visible to all.
Yes, it is visible.
Okay. Okay. So I'm Dr. Sumit Kumar. I'm currently working as assistant professor in UPS Dehradun. So as far as the topic is concerned, or today's presentation is concerned, these will be the major outlines. Means before going to the secure part, one should be very clear about the actual CVR process, because if someone knows what is actually a CVR process is, then understanding a secure CVR system will become a easier task. So that will be, or these are the outlines for today's presentation. So if I start with the history of the image retrieval, not CVR, image retrieval, then it actually starts with text-based image retrieval or tag-based image retrieval, which is formally or informally known as TBIR. So in TBIR, what a person used to do, that it associate a line, might be a phrase, might be a keyword, with each of the image it at one encounters. But the problem is, in past, the number of images are not that much in volume. Means today having a 1 million image is not a big thing. But in that time, the number of images are very less. So giving a description to a particular image is very easy. It is not that time taken. Second thing, since as the number of images starts getting more and more, we have seen that different person give different tag value or different uh, uh, like description to the same image. Okay, means different person might have different perception for a same image. Like if you see this image, okay, and I want to give the description. So I have found these four description with me. One might say that it is a mountain. One might say that it is a lake image. One might found snow a prominent factor here, and Pictionary is always a Pictionary. So that's the problem. Means if I want the images of mountain, I will get this. If I want the image of lake, I will also get the same images. Okay. So this became obsolete. Means this kind of process or this kind of procedure became obsolete. Okay. So in CBIR, so to overcome or to have a retrieval system, especially the image retrieval system, we comes up with a new idea which is called content-based image retrieval, CBIR. So in CBIR, instead of a description, we have visual uh, features. So if you see an image, if I go back, if you see this image, there is some colors in this image. There are some shapes
Sir,
of this image.
sorry for interrupting. Basically, sir, your slide is not moving. It is also not in the full screen. So we are basically able to
No,
see the front page of your slide one.
let me share it again.
First, yeah, yeah, yes, yes,
Let me share it again.
yes, yes.
Is it moving, sir, now?
Uh, no, we are at the basically slide number,
Wait.
but
Is it
with I
moving
think
now?
the contents.
Yeah,
No,
it is
no.
at
Yes,
the
yes,
slide
yes,
number
yes.
4. Okay, it is.
Yes, yes. Now it is moving. So
Now it is
please,
moving. Okay.
yeah,
Okay. So I
can you please
okay. So I'm
make
not
it
moving
the
it to
full?
the full screen mode.
Okay,
Okay.
okay.
Let me try. Let me try the full screen again.
Yes,
Where
yes.
is it moving in full screen now?
Not yet, sir.
Not yet. Okay. So that might be some issue. So I'm not going for the full screen mode.
Okay, okay, fine, sir.
I
Fine.
think is it moving now
Yes,
without
yes, yes.
full
Now it
screen
is
mode?
moving. Yeah,
Okay.
it is
Okay. Okay.
now.
So I'm not going. Okay. So I'm
Yeah,
not going
Yes,
in
sir,
the
it
full
is
screen mode.
moving and it is readable, so there is no issue. You can go ahead in this.
Okay.
yes,
Okay.
yes.
Thank you. Okay. So okay. So in CBIR, there are mainly three primitive features: color, texture, and shape. And there are various techniques to extract these features. Okay. And this process of extracting features is called feature extraction process, which is the most important part of a CBIR process. So in CBIR, entire CBIR process has been carried out in three phases. First, feature database formation. Second, query image feature vector formation, and last is the similarity measure. Now, what happened? Let's understand it one by one, all three phases. Okay. So what happens? There is a image database which someone has. So a CBI provider used to form some image feature set that I want these features in that way. In, because there are various ways. So might be someone can propose a new one and someone can use the already proposed one and combine them together to, and we call the all the features combinedly as feature vector. And when suppose I have 1,000 images and I have extracted features from all the images, then all the features are combined, all the feature vectors are combined together, and we call it feature database. Okay, this is the first part where we construct the feature database. Now the second thing is the query image feature vector formation. So in that, suppose I want a similar image, but that similar means that image must be similar to something or some image. So that particular image, I whose similar image I want to find out is called the query image. Okay. So the same set of features used to be applied on the query image as well, and that particular feature vector is called the query image feature. The last phase is called the similarity measurement. So in similarity measurement, the query image feature vector has been compared with all the feature vectors of the feature database. And the similarity measures could be Euclidean distance, could be Manhattan distance, could be Mahalanobis distance, and there are many more. Earth mover distance. There are many similarity measures. Okay, so one it depends upon the application to application that which similarity measurement one wants to consider for a particular system, and then we retrieve some index. suppose top 20, top 50, top 30. Okay, and those indices, those indexes are passed through the original database so that one can have their similar images. One can have the similar images. Okay. Now, the next part of a CBI system is called the similarity means performance parameters. What are the performance parameters? Suppose I have proposed a CBI system, but on what basis? But on what basis I will say that my system is working better than the other? So there will be some criteria. So these are those criteria. These are three main criteria. Number one, precision. Number two, recall. And number three, F score. So let's understand what are they. So the first, the precision means suppose I have extracted 20 images. Out of them, 18 are correct. Okay. That means the X value here will be 18 and the Y value will be 20. And my precision value means my accuracy will be 90%. That's precision. Now, what is recall? Suppose I have total 100 images in my database and I have extracted, and the total number of images that I have extracted, out of them 18 are correct. That means again the X value is 18 and the Z means the Z value is 100. That means my recall value will be 18%. The third thing, which is the F score of the, or the, which is called also the F mean. This is the harmonic mean of precision and recall. Okay, so this single value can say or can elaborate how good your system is. Means the greater the F score, the greater is the performance. Okay, so these three parameters are widely and accepted and used for any CBI system, for the comparison, for the elaboration, okay, for all the purposes. Now, we have learned what is a CBI system, but a secure CBI system a bit different from the conventional CBI system. The main difference comes in two parameters. Number one, the images are not stored with the original owner. It been transferred to some third party cloud, which might be secure, but in real time application, we cannot fully trust it. Okay, so first thing, the image, every image of our image database must be encrypted. Second thing, when the feature extraction takes place, that means when the feature database is formed, the feature vector database must also be encrypted, because in CBIR, one, whether it's an eavesdropper or any other kind of unauthorized person, can get the feel of the image, that what kind of image it might be. So each feature vector has to be encrypted. Okay. Now, I suppose someone encrypt the image, someone encrypt the feature database and send it to the cloud. But in cloud, the similarity measurement must also be taken care in the encrypted mode. Means I do not need, or the cloud server do not need to decrypt the feature vector in any feature vector, whether it's a query image feature vector or it's a any feature vector of a feature database. It must not be encrypted. It must be encrypted. It shouldn't be decrypted, because I have come across several examples where illegal distributions has been done by the cloud server administrator. Okay, so these are the main tasks of the secure CBI system, any secure CBI system. That first thing, the image must be encrypted. Second, the feature vector must be encrypted, and the similarity measurement, which needs to be taken care at the cloud level, it should also be done at the encrypted level. Okay, so these are the three things that one needs to deal with, or one needs to find the answers of. Now let's see how I have proposed or I have come across. Okay, so these are my motivation for a secure CBI system. Number one, since the number of images are very large, so I need to design a image crypto system which provide which has the capability that can deal with very large amount of color databases or large amount of color images. Okay, must and okay. So if it is encrypted, then it must be capable enough so that it can deal with the data security from various unauthorized user as well as from the remote server, means the cloud server. Okay, and finally, I have designed a proper secure CBI system, means transferring the images from the cloud to the authorized user in a secure manner. Okay, so the very first thing here, if you can see, is the color image crypto system. So let's see how I have designed one color image crypto system. So this is the input color image first. Okay, so a traditional or conventional RGB image I am taking here. So it has three color bands or color channels: red color channel, blue color channel, and green color channel. Okay. Now, as we know that each color band or each color channel, the intensity levels are 0 to 255. So if I divide into their binary form, so there are totally 8 planes. Okay, we call it bit planes. So I have divided each of them in their respective bit planes, means 8 red channel means 8 red bit planes, 8 green bit planes, and 8 blue bit planes. Now I just shuffle them, okay, in a particular order. I'll tell you from where that order will come in the later part. Okay, so there is a particular order which is will be like one of the key in the encryption. Okay, and just shuffle them. Okay, so these 24 bit planes are just shuffled. So when they are shuffled, so the very first 8 bit planes after the shuffling that I got it. I call them RM, means uh, premature uh, red color channel. Similarly, the suppose from 0 to 7, I call them RM, small RM. From 8 to 15, I call GM, and from 16 to 23, I call them BM. Okay, these are like intermediate red, green, and blue color channels. Now, to enhance the security further, okay, I have used two-dimensional logistic map, which works on a single key. Might be on 2 keys, some logistic map, but I have used single key. So I just XOR them. Okay, I have created a logistic map of the same size as RM and just XOR their values to get my final uh, red channel or encrypted red channel component. Similarly, encrypted green channel component and blue color channel component. Okay. Now, as I have fragmented it in the initial part, now I have just defragmented them and call it intermediate shuffled image, intermediate colored shuffled image. Okay. Now, the same process that I have taken in the one go, I have applied many rounds. Okay. And after applying for 20, 50 rounds, I finally got my encrypted image. That's how that's how I got the image encryption. Means I have encrypted my image. Okay, so that's the first part. Now these are the like logarithmic steps that I have applied while writing the code using the MATLAB. Okay. Now image has been encrypted now, but I need to prove that whether my image encryption technique is sufficient enough, or I can say that I need to prove whether the image is encrypted well or not. So there are some parameters that I need to test. Okay. So now if you see, the first image is of the original image. I have decomposed the second row showing their individual components. Means first is the red component, second is the green component, and the last is the blue component. Now, these are the individual. In the third row, the ciphered one are the encrypted individual encrypted components, and in the last, the combined colored encrypted image that I have shown. So these are the visual results of my uh, technique, my encryption technique. Okay, so these are the visual results. Let's do the analysis of the encrypted image. Okay, first thing is the entropy. Entropy says how much information does it have. It mainly says about the information that one can get. It has been already stated that if you want to achieve a good encrypted image or good image crypto system, then your entropy of the cipher image must be very close to 8. Very close to 8. Okay, so if you can see, the entropy of the cipher image is 7.9981 or 7.9983, 7.9984, which is very close to 8. That means my system or the proposed system has produced a very good encrypted image. Second thing is the histogram based analysis. Okay, for a symmetric or for a good encryption, okay, it it has been mentioned various times that it should produce a symmetric histogram. Means there shouldn't be a spike or there shouldn't be any kind of major uh, ups and downs in the histogram. Okay, so I have shown the histogram of original red, green, and blue channel and their subsequent ciphered image histogram. Okay, which is quite symmetric. Again, it proves the usefulness of the proposed system. The next thing is the PSNR. PSNR is quite relatable. Means if two things are not that much relatable, means if your value of PSNR is under 10, okay, that means those two values are not relatable. So I have found the PSNR between the original color component and the encrypted color component. Means unencrypted R channel with encrypted R channel, and I have found these are the entropies from the different color channels individually, which is very close to like 7 or something, in the range of 7 to 8, which is very minute. That means they are not related. Okay, so I have proved till now that okay, these are the proposed system is working very fine. Now the second, if I go back, the second was providing data security from the server side. Now, in the server side, not only the image has been transferred, but the feature vector is also transferred. So, as the feature vectors are also transferred, these must also be encrypted. So, for the encryption of the feature vector, I have used KNN process. Now, what it is? Okay, in KNN process, the KNN process can also be divided in 3 parts. First is the data feature database encryption, feature vector database encryption. Second part is the query image feature vector encryption, and the third part is the similarity, that too in encrypted domain, means without decrypting the feature vector. So let's see. So suppose here I have denoted FB is the feature vector of an image. Suppose the size is D. D, you can say any integer, suppose 20. Suppose the D is 20 here. Okay, so I have to design a matrix M of 21 by 21. But the only thing is that it should be invertible. Okay, invertible matrix means I am able to get the inverse of that matrix. Means M inverse should also exist. and there is only one criteria that the sorry, that the modulus of m must also be non-zero, any value but non-zero. Okay, so this is the first key. Now the intermediate part is I created the transpose of the feature vector, and with the addition of the value minus 0.5 and the modulus of fv square and then the transpose, if I combine them together and take the transpose, that will be my intermediate encrypted feature vector. Now for the fb dash, which is the final encrypted feature vector, the fv dash or f transpose fb cap is multiplied with m transpose to get the final encrypted feature vector. So this is how the feature vectors are encrypted. If you see in real time, okay, the values are totally apart, just totally apart. There is no connection. Second thing is the query image feature vector. Okay, okay. Now the query image feature vector has been done by the registered user. Okay, it has nothing to do with the image owner. Okay, so the authorized user will select any random number r, and it take the transpose of the query image feature vector, just include 1 in the last, take its transpose, and then multiplied with that random number. This is called intermediate query image feature vector. Now the m inverse part, for this step, only for this step, the condition has been applied that the selected m must be invertible, because to encrypt the query image feature vector I need the inverse of m. Okay, so now m inverse is being multiplied with the intermediate query image feature vector to get the final encrypted query image feature vector. Okay, so now I have encrypted all the feature vectors and my query image feature vector. Now the third part comes that how we found the similarity between them. Okay, so the similarity, finding the similarity is a bit easy. Means I just take the dot product of all the feature vectors with the query image feature vector. Okay, so if and just arrange them in the decreasing order. Okay, in the decreasing order. So the first means the feature vector which produce the less distance will be closer to the query image feature vector. That's how this KNN works. Okay, so in this system I have 4 entities. The image owner. Okay, let me just give a brief introduction about all of them. Image owner, this is a person which has the original database. Okay, it means this is the one who needs actually the cloud to store the data. Second is the key management center. This is a third party organization which is totally trusted, and its task is to provide various keys. Okay, now whether so, as you can see that in image encryption I have shuffled the image in some order. That order is a key which is provided by the key management center, and there are various other keys like m. Okay, that all are provided by the key management center. Third is the authorized user, means a user which is fully authorized, trusted, and wants to find the similar images from the database of the image owner. And fourth part is the remote server. Okay, like a cloud server. So these are the 4 entities. Okay, okay. So let's understand what is the role of each and every one. Okay, so the role or what is the work here for the image owner. So image owner has the image database, the feature database. Okay. So it gets the key M, okay, and the key for the individual image for the encryption. So it performs the image encryption and feature vector encryption. And then the encrypted image database and encrypted feature database it sends to a remote server. These are the tasks of a image owner. Okay, means calculating the feature vectors, encrypt the images, and encrypting the feature database. These are the three tasks, and then just transfer those encrypted databases to the cloud. Next, the KMC or the Key Management Center. Okay, it first perform the key encryption or key exchange protocol between the image owner and the and itself. Okay, like we have studied like Diffie Hellman and various other kind of key exchange protocol with you know uh, not only authorized a particular entity but allows the key to move from one entity to another. Okay, and after the KAP has been set up between KMC and the owner, it sends the M and SK. Now it also needs to send the key to the user also. So again, the KAP key exchange protocol must also be set up between them, and it sends a uh, local key to the image owner. Sorry, user. Now user encrypt the query image feature vector using the key of uh, KMC. Now, as it receives the KMC, decrypt the image, or sorry, decrypt the uh, query image feature vector, and encrypted again with the M inverse, okay, and send it to the cloud. When the cloud server performs the similarity, it sends the indices of the images along with the encrypted images. Okay, now the KMC sends those encrypted images along with only the keys of those images only, not the whole, but only on those images back to the authorized user so that it can decrypt and get the original images. The third entity here is the registered user. So it generates the query image feature vector, performs the key exchange protocol between the KMC and the registered user. Then the KMC he got the temporarily key from the KMC, encrypt the query image feature vector from the KQ, and it receives the encrypted images along with the key from the KMC. The last entity here is the cloud server. Okay, so the main task of the cloud server are two things. First, it provides the storage to the uh, encrypted image database and encrypted feature vector database. Then it performs the similarity between the encrypted feature database and encrypted query image feature vector. And then when it finds the indices after the finding the similarity, it sends the indices along with their encrypted images back to the KMC. Okay, so these are the particular rules or work in this system for the individual entity. Now let's see overall how the system looks like. Okay, so uh, if you can see here, all the four entities are there. Okay, so it starts with here. It has uh, a original image database. Feature extraction takes place. Then the encryption of feature vectors takes place. Then there is an image whose image encryption takes place. Now, uh, and it sends those images or those encrypted image databases and those encrypted feature databases back to the uh, cloud server or the remote server. Now, when the query, when a user has a query, it generates the query image feature vector, performs the key exchange protocol with the cloud, oh sorry, with the KMC, and then receives the temporary key, encrypt the image with that, and then uh, encrypt the query image feature vector with that key and send it to the KMC. Now KMC again decrypt it, encrypt again with the M inverse, and send it to the uh, cloud server. Now cloud server finds the similarity between them, uh, and then return the indices along with the encrypted images, the set of encrypted images back to the KMC. Now KMC, as it got the indices, just take out the key for those indices along with the encrypted images, just send it back to the registered user. Okay, so that's how the whole system works. Let's talk about now. So this is the overall system, overall secure CBI system that I have worked on. Now let's talk about the results of it. Okay, so in CBIR there are various databases that are, those are benchmark databases, widely used, widely accepted. So I have drawn results based on those databases. So let's see and discuss one by one. Okay, so the number one is the WANG, or which is also called Coral 1K database. It has 1,000 images from 10 categories, means each category has 100 image. I have drawn results for various number of output images and their precision, recall, and F-score values for individual image for all the categories, means all 10 categories. And I have shown them using a particular graph. Okay, so as the number of images are increased, okay, the precision value used to be on the declining mode and the recall is on the uh, up mode. Okay, so these are the databases for WANG database or Coral 1K database. Now, what I have done here, that I have found the images or the my results both in encrypted mode and in a normal conventional CBR mode. Means I have adopted Euclidean distance as a similarity measurement and KNN also as the similarity measurement. Okay, for KNN has been carried out on encrypted feature vectors, and Euclidean distance has been carried out on simple feature vectors. And I have concluded that, and I have found using the results that in encrypted mode, the results has been degraded a bit, not by much, but yes, a bit. But here, uh, there should be a trade-off. I have always wanted a trade-off between the retrieval system, between the retrieval efficiency of a system and the security part. And security part is more I'm concerned of. So a bit degradation of the uh, system, means the retrieval system, is totally acceptable. Okay, so these are the results for bank, means for Coral 1K. Now, another database that I have considered here is the Coil 100. Okay, it has 100 total 10,000 images from the 100 categories. So means one category has 100 images, and I have drawn the results again with uh, both the using both the distances, means in encrypted domain and using decrypted domain, means in safe mode and in normal or conventional CBI system. Okay, I have done the same with the produce. This is all another database which has 1,400 images from 14 categories. Okay, so that's how the system like results in the retrieval efficiency. I have shown what is the security part of it. Okay, so in the last, to conclude my work, I can say that the proposed CBI system is what here I have included color, texture, and shape-based features for forming my feature vector. Next, I have proposed a color image crypto system. I have shown its uh, kind of analysis stats based on which I can claim that it is working very fine. Okay, the KNN, which has ASP asymmetric uh, multiple level encryption based technique inbuilt in it, which I have used for the encryption of the feature vector, for the encryption of the query image feature vector, and then finding the similarity between the query image feature vector with the encrypted feature database. Okay. And then I have shown there is a four-party system. Okay, like image owner, KMC, uh, authorized user, and the cloud server or remote server to set up my secure CBI system. Okay, so that's how a secure CBI system works. Okay, so that's all from my side. Thank you for listening me so patiently. Thank you for giving me enough time. If anyone has any questions regarding this about the future, means how one can proceed in future with the same kind of work, so one is totally welcome.
Yeah, thank you, sir, for the nice presentation on secure image retrieval in cloud storage. And for the participants, if you have any query, you can type it on the chat box. Okay, we can discuss on that one. Okay, so for the basically question, if you have any question, you can put it on the chat box. We will discuss. Okay, so Sumit sir, we will wait for the next 2 or 3 minutes for the questions.
Yeah, sure.
Yeah.
Just for the future aspect, I can say that if someone wants to work in future with the secure CBI system, with such kind of CBI system, then I have used here the handcrafted system. Uh, yeah, okay, I'll tell you. Dhananjay, I'll tell you. Uh, okay, so one can think of using D features, how it will, how one can extract D features from the encrypted image. Okay, so that will be a good enhancement for the this system. Okay, so what was the question? How authority to encrypt the images is decided? Okay, so the image encryption is a process which is decided by the owner image owner, and the key is being provided by the KMC. Okay, so image owner has the algorithm to encrypt the image, and the key values it got after the key exchange protocol from the KMC. So as it got the key, it can, or the image owner can encrypt the image.
Yeah. Any other questions?
What if KMC? No. That's the assumption. That's the only assumption. In if you read or if you go with the cryptography and network security, there are various cases where a third-party organization, a third party, has been considered as totally trusted. Uh, in India, uh, there is a this is the third party how the banks are working so smoothly because the public private key or the SSL 128, which is currently implemented in India, has been taken care by a third party or third party player. So no, KMC cannot reveal. It's a totally trusted party.
Yeah. Any other questions? Okay, so we will wait for the next 1 minute. If
Yeah,
we
sure.
will get any question,
Sure.
then fine. Okay. Yeah.
Sir, I think there are no questions, but if we have this PPT and later when students actually they do revert, so we can share the PPT and
Yeah,
we can connect with sir, because I just noticed that some of our PhD scholars are not here who actually are working in this area. One of them is not here. So if they follow up, sir, we can actually connect them to you, sir.
yeah,
You will
sure.
guide them
Yeah,
on
sure,
details.
sure, sure. If later you receive some
So,
questions, you can just tell me. I'll write the answers and send it back to you.
so, sir, and we also have a YouTube streaming which is happening parallelly. So we actually have that link and we share it with students. So at any point of time, if
Hmm.
they see that they would like to know anything, so so we will
Okay.
connect them to you. So,
Yeah, sure.
so Abhinav sir, I think we can move ahead.
Yes, yes, ma'am. I think we do not have any question now. So now, yeah, present, sir, I think.
So this is Dr. Brajendra Pratap Singh.
Yes.
So, sir, on the behalf of Department of Computer Science and Engineering, Faculty of Engineering and Technology, Shiksha Anusandhan Deemed University, uh, I extend our heartiest thanks to Dr. Sumit Kumar for delivering this good lecture on this particular topic, which is related on the image retrieval in the cloud storage. And I also would like to thank our organizing team, which is belonging to the Computer Science and Engineering Department. And I thanks to Dr. Professor Debahuti Misra, who is the convener of this program. This particular SOA Wall program is comprising 52 lectures, that is a weekly academic webinar program. So, and I also thank you all of you to just completing this webinar program successfully, because this is the last lecture of this particular SOA Wall program. And I also thanks to Dr. Abhinav Kumar for inviting the Dr. Sumit Kumar for this nice and informative lecture. And I would also like to thank all the participants for their participation in this particular lecture and for their keen interest into this one. So once again, I thank you all of you, the speaker, the organizer, the invitee, and all the participants. Thank you all.
Thank you, sir.
Thank you, sir.
Okay, so we are stopping now. Thank you all. So all of you
Thank
can
you.
leave now. Okay.